Find the value of the discriminant. Okay? Remember, the discriminant is the part underneath the radical, b squared minus 4ac. So we're going to identify a, b, and c. Always good practice. 7, negative 11, and 5. So, negative 11 squared. Be careful. Don't type in your calculator, just negative 11 squared. Otherwise, you'll get negative 121, and it's positive. Minus 4 times a times c. Now you just crunch the numbers. 121 minus 7 times 4 is 28, and 28 times 5 is 140. When you subtract that, you get negative 19. So, the discriminant is negative 19. There are no solutions, and they are imaginary or non-real. Because that would be an I. Okay? Can't do anything yet. Got to move this over. X squared plus 22x plus 121 equals 0. Now we can identify A, B, and C. 122, 121. Again, b squared. So that's 22 squared minus 4 times 1 times 121. Well, 22 squared is 484. Minus 4 times 121, which is 484, which is 0. So my discriminant is 0. When I have 0, that means, let's go over here real quick. This means something like that or this. Never crosses. When you have a 0, it means something like this, where it just touches in one spot and goes back the other direction. So that means there's one solution and it is real. Want to gather what this might be? Again, has to be 0, so we move this over. 10x squared minus 13x minus 3 equals 0. Didn't really give myself room over there, so I'll do my A, B, and C here. 10, negative 13, negative 3. B squared, negative 13 squared, minus 4 times A times C. Well, 13 squared is 169. Negative 4 times 10 is negative 40. Times negative 3 is plus 120. And that gives me 289 for discriminant. Which means, in that case, we're talking about our traditional 2 points of intercept on the x-axis, and they're both real. Okay, quadratic formula. Remember, that's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But before you do anything, you need to move everything over to the same side. 12x squared plus 9x. Careful here, when you add 17, it's 17 minus 2, that's 15. We want to identify A, B, and C. 12, 9, and 15. So, x equals the opposite of b, plus or minus square root of b squared minus 4 times A times C all over 2a. Sorry. 12. 2 times 12. So, x equals negative 9 plus or minus 81 minus 4 times 12 times 15. 720 over 24. Well, 8 81 minus 720 is negative 9 plus or minus the square root of negative 1 times 639 all over 24. Now I'll tell you, 639 is kind of a nasty number to break down. So even though I usually say start high, I'm starting with something I know works. So 4 doesn't work, but 9 does. And 71 is a prime number, so I know I'm good. If I would have ended up with a number that had another number inside of it, perfect square, I might try to find that bigger number. But I'm ready to go. So my answer is going to be x equals negative 9 plus or minus. 71 is going to be stuck inside. Square root of 9 is 3. And the I comes out, and this is 24. Now, I have one more step, because everything is divisible by 3 on the outside. So that's going to be negative 3 plus or minus I root 71 all over 8. Now it is finished. Nasty, but finished. Okay, move this over. Negative 3x squared plus 4x plus 8 equals 0. A, negative 3. B, 4. C, 8. So now we're ready to do our equation. X equals the opposite of B plus or minus square root. B squared minus 4 times A times C all over 2A. That's negative 3. So x equals negative 4 plus or minus 4 squared is 16. 4 times 3 is 12. Negative times negative is positive. And 12 times 8 is 96. All over negative 6. So 96 and 16, we have to add those together. And it's 112. Over negative 6. But we have to see if 112 is divisible by any of our numbers. And it is. And even though it's divisible by 4, you want to try to find the biggest one. And 112 is actually 16 and 7. So that's going to be x equals negative 4 plus or minus square root of 16 is 4. Radical 7 all over negative 6. And since I could bust that up and reduce everything by negative 2, or positive 2, doesn't really matter, I'm going to get for a final answer, x equals, let's do negative 2. I'll just show you what I'm talking about. If this was negative 4 over negative 6, plus or minus 4 root 7 over negative 6, we would break this down. How would it break down? Well, negative over negative is positive. Okay, so that's 2/3 plus or minus. Again, this would be 2 radical 7 over negative 3. Okay, we need to write these in vertex form. Try to remember the steps for vertex form. Basically, you complete the square. We need to move this 5 over, except this time we have a y instead of the 0. So we get y minus 5 equals x squared minus 8x. There's our space. Now we just complete the square. Minus 4, do our trick, square it, add 16. We do that to both sides. What it gives me is y plus 11 equals x minus 4 squared. Now, y plus. So I'm not going to do the square root method here to get it by itself because I have two variables going on. All I do now is move this over and get y by itself. Y equals x minus 4 squared minus 11. So what's the vertex? 4, negative 11. My vertex symmetry is x equals 4. Let's do it again. Move the 5 over. Y plus 5 equals 2x squared minus 4x. Okay? Now remember, this is one of those tricky ones. So we're going to factor out 2 because it has to be x squared. I'm going to leave our space. Now we do our trick on here, negative 1 squared, and we're going to add 1. But remember, we're not really adding 1, we're adding 2. 2 times 1, which means we have to add 2 to this side. That's the only part of this you got to be careful about. So that's y plus 7 equals 2 x minus 1 squared. Then we move the 7 over. Y equals 2 x minus 1 squared minus 7. So what's my vertex? 1, negative 7. And my axis of symmetry is x equals 1. Okay, identify the form of the quadratic equation that provide the following information. So, when you have 2 parentheses, those are intercepts. It's going to open down, because it's sad, it's negative. What are the intercepts? Negative 7 and negative 3. I'm going to put those on here right now. The axis of symmetry is going to be halfway in between those. Negative 7 plus negative 3 divided by 2. That's negative 10 divided by 2, so x equals negative 5. So I put my dotted line right there on negative 5. Notice it's 2 spaces away either side. The vertex, I put the negative 5 back in here and here. Don't forget the negative 2 on the outside. And what that is negative 2 times 7 minus 5 is 2 times negative 2. 2 times 2 times 2 is 8. And it's going to be negative. Wait, positive. The negatives cancel each other out. So that's 5, 8. Sorry, negative 5, 8. Now, a little quicker. Once I knew x was negative 5, I could have just plugged this in my calculator, gone to negative 5, and also seen that on the table is negative 5, 8, or at least to verify. Is it max or min? Well, it's going down, so it's a max. The y-intercept, on this one, we don't have it in that form. We have 2 choices. We can FOIL out and distribute negative 2 and put it in standard form to see where it is, or we can go to our calculator and put it in. Now, I'm not going to show you because you've seen it enough times on the screen, so to save time, you know how to enter this in the calculator. You can put this in and get some other points, like negative 6, positive 6, and negative 4, positive 6, and even negative 2, negative 10. And negative 8, negative 10. So that gives you a good idea of what this is going to look like. something like that. That was pretty bad. But now you can tell that the y-intercept is going to be way down there. Like I said, you have two choices. We could FOIL it out and shoot to -2, or just go to our calculator and look for an x of 0. And you will find out the y-intercept is at 0, -42. The domain, as we said, is not changing on most of these. The range, how low does it go? -infinity. How high does it go? That's our +8. That's our y from the vertex. And the zeros, we already said that, -7 and -3. Those are the same things as x-intercepts or solutions. Again, we have intercept form. This one's going to open up. The intercepts are going to be at -2 and +4. The axis of symmetry is going to be -2 plus 4 divided by 2. That's going to be 1. Which is 3 away from each of those. So I'm going to plug 1 back in. 1 plus 2 times 1 minus 4. That's 3 and -3. So that's -9. So that's going to be at 1, -9. It's going to be a minimum because it's opening up. Y-intercept, again, go ahead and just put this in the calculator. Parentheses x plus 2, parentheses x minus 4. And when you do that, and you go to the table, you see 0, -8. Again, the other way to find out would be to FOIL this and find out, 2 times -4 would be your -8. Once again, use your calculator. There's your sketch. The domain, again, -infinity to +infinity. The range, how low does it go? That's our y from our vertex, right here. And how high does it go? Up to +infinity. And we already said our zeros were at -2 and 4. Okay, number 38. This is in vertex form. We get the vertex here and here. It's going to open up because it's positive. And the vertex is going to be, well, the vertex is going to be 3, 2. Now, once again, if you're not sure, if you can't remember what the rules are on these, real quickly, just put this in your calculator. Put in parentheses, x minus 3. I'm having trouble. Parentheses squared plus 2. And just hit graph. So if you get confused whether it's 3 or -3, don't guess and be wrong. Guess, that's fine, but check it in the calculator. When you put this in, you will see that it's graphing in the first quadrant. So therefore, the vertex is at 3, 2. Where's the axis of symmetry? Right there, at x equals 3. Get it right here, x equals. Now, since it's opening up, it's going to be a minimum. Y-intercept, once again, we don't know that. To know that, we have two choices. FOIL this, and then add the 2. And if you think about it, -3 squared is 9, plus 2 is 11. So it's probably going to be at 11, 0, 11. But we can also go to our calculator and check. And I do see that 0, 11. So 0, 11 is about right there. And then again, you just go ahead and get some points off the calculator. 1 is at 6. 2, 3. We already know 3, 2. Then 4, 3. And 5, 6. And 6, 11. And now we can roughly sketch our parabola. The domain, not changing, -infinity to +infinity. My range, how low does it go? We look right here. How high does it go? Right there. My roots? None. It's not crossing the x-axis. And roots and zeros are x-intercepts. Okay? Again, this is in vertex form. It is opening down. Notice the negative in front of the 3. The vertex, we're going to do that first. That's at 5, 8. Again, put in your calculator if you're not sure of how it's going to look and confirm it. You may think it's 5, and you are correct. It is 5, but why not at least double check? And then, now that you know the vertex, you know the axis of symmetry is at 5. So I can go here before I do anything else. Just put my axis right here at 5. 5, 8 is my vertex. It's going to be opening down. Maximum or minimum? It's going to be maximum because it's going up. What's my y-intercept? I don't know. I have to square x minus 5, distribute negative 3, then add 8. Or I just go to my calculator, look for 0. And it's all the way down at negative 67. I'm not going to graph that. I'm going to put a few more points on to be able to graph it, like 3, negative 4. And 4, 5. And 6, 5. And 7, negative 4. Everything else off the chart. And I just roughly sketch like so. The domain, again, negative infinity to positive infinity. The range, how low does it go? Negative infinity. How high? Right there, 8. Oops, these should be inclusive. I haven't been doing that, have I? I'm so sorry. Inclusive. Somebody's probably yelling at me. He's trying to get some gum out of this. Inclusive. Inclusive. Boy, that was a rookie mistake. Sorry about that. Now my roots, on this one, we have to estimate. And I would look at your graph and confirm where they come between. Like it'd be a sloppy graph. But if you look at your graph, you can see it's between 3 and 4, which you can kind of see on my drawing right there. It's a little closer to the 4, I think. No, it's probably about halfway, so it's not bad. And then it's between 6 and 7. Now you can see my sloppy one. My first one was going over here, and I cleaned it up. It's pretty close to 7. But it's between those two numbers, 3 and 4, and 6 and 7. Somewhere in there. And that's all you have to say. You don't have to find the exact number now.